Welcome to lesson 14, blood pressure and bias. I'm going to go ahead and circle the word bias. When blood pressure is measured, two readings are taken. The higher reading is called the systolic pressure, which is the pressure as the heart beats. The second measure is the diastolic pressure, or the pressure between beats. You may have had your blood pressure measured by an arm cuff. Newer devices have been developed that can measure blood pressure by simply attaching a cuff to a person's finger. What did you learn about blood pressure from your reading in preview assignment 14A? This is a great time to hit pause, jot down a couple of thoughts, and reflect on the reading from the preview. Go ahead and look at your objectives and get part 2 or question 2 started. Then come back and we'll talk some more through this lesson. So in your reading, you might have noted that the systolic pressure of 140 mmHgs or greater is considered high. Between 120 and 139 is considered pre-hypertension, and less than or equal to 120 is good. The objectives for this lesson include that we're going to understand that error in an estimate has two components. It has sampling error and non-sampling error. Non-sampling error arises from sources other than sampling, such as non-sampling error could be bias. We're going to be able to determine when a sampling process can yield non-sampling errors due to bias. So in question 2, it tells us to recall that the blood pressure for 30 adults that it was measured with the new finger cuff device, and it's shown in the dot plot. The systolic mean being 119.1. So somewhere around here. Afterward, the pressures were measured again with a reliable inflatable arm cuff device. The mean systolic pressure was 115 6/10. Whoa, down here. We assume that this one, the one taken with the reliable source, is the correct average. So part A says plot this mean with an X. So right here is the mean taken with the arm cuff. Then part B says we assume that the mean of 115 6/10 is accurate because of the reliability of the arm cuff device. The difference in the results between the two methods implies that the mean of the finger cuff measurement has some error. The error is the difference, I would be underlining this, the difference between the estimate from the finger cutoff device, not finger cut off, wow, finger cuff device, and the actual accurate mean. So what is the value of the error? Well, write a contextual sentence about the error. So in our case, we have our finger cuff device measuring at 119 1/10. When time goes by and they can retest the mean, they can retest the blood pressure using the arm cuff, we get 115 6/10. In other words, a difference of 3.5. And what this could mean is that the finger cuff method is measuring systolic pressure too high by about 3.5 mmHgs. Part C, do you think that the distribution of the blood pressure from the finger cuff device when compared to the mean value of the arm cuff device is due by, now this is a big question, do you think it's due by chance fluctuation, just happened, or do you think there is some sort of bias in the measurement? You write down your thoughts and your answers, but it seems that's pretty high. That's a pretty big average for the difference, and it is an average and not just one measurement. It seems that there is something that is influencing the measurements. Most of the finger cuff measurements are above the 115 and 6/10. So if you look, all of these measurements right here and these up here are all above the average that we think we can trust. There seems to be some bias in the measurements. So looking at part D, which of the statements below is true, and explain your answer. So the part A asks or says the blood pressure measurements are all higher than the reliable average. And if we look over here, they are not all higher than the reliable average. B, the distribution of the blood systolic pressures is shifted to the right so that the correct mean is off center. And if we notice, the finger cuff has a normal curve, a distribution there. But if we were to draw a normal curve where the other mean is, it is shifted, as it says, to the right. So we think the red one is the right one, but the blue is shifted to the right. So some kind of explanation could be that some of the finger cuff values were below average. We do not have the arm cuff measurements for each individual to compare to the finger cuff measurements. So part E says, in this context, describe the meaning of the word bias. And in this case, bias is a tendency for most blood pressure values to be measured by the finger cuff device as higher. Right here is where we think the real mean is. But our bias is that the finger cuff device is higher than they should be. Remember, we're going to be covering several vocabulary words, and you need to put them somewhere, like flashcards, glossary, something where you're able to remember the nuances of these words. So starting with question 3, again, hit pause if you haven't already looked at this, work on question 3 and 4, and then come back and work on them with me. But while you're working on them, make sure that you have something on which you are documenting all of these words. So for question 3, we have previously thought about sampling error. Sampling error arises when, make sure you're making note, we use a sample instead of the entire population to make an estimate of a population parameter. In other words, we cannot sample, or we cannot take everybody in the whole wide world's blood pressure using the finger cuff. So we have to do a sample. And anytime we're using a sample instead of the entire population, then there could be error. Error from other sources is called non-sampling error. A primary source of non-sampling error is bias. Bias occurs when some flaw in the design or implementation of a study results in a tendency of the measurements to be too high or too low. Part A, by the definition of bias given above, it really does seem that there is a flaw in the design or implementation of the study that is causing measurements and it's a question, does it seem that there is something going on that's going to make our measurements too high or too low? And yes, it seems that most of the measurements are too high, which indicates there is something wrong. Part B, can you guess the flaw in the study that might be the bias evident in the data values? A couple of things you might answer or think of or write down is that there may be a problem with the device. Also, the technician may or may not know how to use the device correctly. Add more, whatever you think could be going on wrong or causing the measurements to be too high. Part C, can we use the mean systolic blood pressure from the 30 random finger cuff measurements to make an inference about the mean for all adults? Write what you want to write, but Because these values seem to be biased, they yield a mean, an average, that is actually higher than it should be, and that can be misleading if it's used as an estimate for the mean systolic pressure for all adults. Part D, researchers plan to use the finger cuff device to measure the outcome of a new blood pressure medication. They're going to use this flawed device to give information on a new medication that they're studying. How will this affect the doctor's perceptions of the medication's effects? Write down some information. Something you might consider is that doctors are going to believe that the individuals using the finger cuff device, that their blood pressures are higher than they actually are. These inaccurate measurements may impact how doctors view the effects of the medication, but possibly not if they are comparing to a control group that is being measured with the same device. So it's not good. It has a flaw. Question number 4. So as we go along in these lessons, we'll pause often to summarize where we are, what we're noticing for a good study, things that must be considered for us to have reliable results. So part 4, question 4, says summarize the key characteristics and important concepts that must be considered when selecting samples and collecting sample data. A lot of things you can write down right now. You might go ahead and write down some from memory. You might look through your notes and write down some. And you might add some like this, that the data are going to be influenced by the way that we gather them or measure the data. If it's a survey, how are we asking the survey questions? Who are we asking? And the measure, like the cuff, how was it taken? Was it taken accurately? And when this occurs, we're going to have sampling error. And it's going to be introduced, and we can call it bias. When sample data contain bias, I don't know how large you can write this word, but when sample data contain bias, they become useless. They are useless, and we cannot make conclusions about the population from which they are sampled. I don't care how pretty your study is, how tedious it is, and how much money you spent on it. If it's got bias, it stinks up the whole thing, and your whole study becomes useless. And that concludes Lesson 14A. Look at your syllabus to see if you have more lessons for this week. So keep going if you do, and if not, celebrate being done another week, and I'll see you on a video soon.